So we're asked to differentiate this quadratic here from first principles. Okay, so when I do first principles, I always do a little bit of the curve here. Okay, and I'm going to consider 2 points. So I'm going to consider the point P and the point Q. So my point P is just a general point on that curve for value x. Okay, any x, it doesn't really matter. Okay, general x. So if I've got a general x value here, of course my y would then just result in this one that you substituted in to get your y, so it'll be all of that there, 2x squared minus 5x plus 3. With differentiation from first principles, what we do is we go to a point Q, which is a distance h across, isn't it? Okay, if you recall, so we're literally going across a distance h there. So the x value here then, well, if p is x, going across the distance h, my x value there will be x plus h, won't it? We're adding it on. So if my x value now is x plus h, I can work out what my y value is just by subbing it in. It's going to be quite large here. Okay, but we'll just sub it in here as it is. Okay, so there's my x value here, which is x plus h, and then my y value will result in all of that. Now, to differentiate from first principles, what I'll do is I'll work out the gradient of that line there, PQ. Okay. Okay, so the gradient of that line PQ, or we'll call it a chord, PQ. Of course, to remember, to work out a gradient of a line, we just think about the difference in y's divided by the difference in x's, y2 minus y1 over x2 minus x1, what you learn from coordinate geometry. And then we're literally going to sub in all these values. So I'm going to need quite a bit of space here, long line there for my divisor. And a y2, y1, x2, x1, I need to identify these. So if I call that my x2, y2, and this one be my x1, y1, that would make sense. So my y2 is all of this, okay? And then my y1 is all of that. So I've got to take away this. Now, because I've got to take away, as it says here, minus y1, I've got to take away all of this. Remember that I'm taking away all, so the minus will apply to all of this. So please put it in a bracket, okay? Just to remind you that the minus will apply to every term here. On the bottom then, x2, which is x plus h. Take away then x1, which is x. The x's will cancel, okay? The x's will cancel. And you just left with h. So on the top then, we just need to tidy this up a bit, start expanding, okay? I think here we'll maybe write the bracket out twice, just to begin with, because that's what it is, squared. And then we could start expanding this. So minus 5 times x is minus 5x. Minus 5 times h is minus 5h. I got plus the 3 there. Now remember what I said earlier, that minus applies to all of y1 here. So minus the 2x squared. Minus the minus becomes plus 5x. And then minus then the 3 here. And what you'll find is straight away you can identify things that will cancel. So you've got a minus 5x there will cancel with the plus 5x, and you've got a 3 here which will cancel with the minus 3. On the bottom you've got h. So let's then expand this here. Now I'll keep perhaps the 2 outside for a minute. Okay, but I'll expand the pair of brackets here. So I'll do first is x squared. Outers will be xh, inners will also be, well, hx or xh as well. So you've got 2 lots of xh, and last then will be h squared. Take away 5h, take away 2x squared. On the bottom you've got h. We'll then multiply with that bracket. So that 2x squared plus then 4xh plus 2h squared times everything in there by 2. Take away 5h, take away 2x squared, and on the bottom h. And again on the top we look to see if anything cancels. 2x squared here will cancel with that minus 2x squared, and we're left with this then. And you'll notice here on the top, everything has got a h in it, isn't it, on the top? So what I can do, because everything's got a h in it, factorize out a h bracket. So inside the bracket then, because I factorize out the h, it'll be h times 4x will give me that, h times 2h will give me that, and then h times minus 5 will give me that, all over h, and then of course, because we've got h on the top, h on the bottom, it's common factors, we can divide them, it gives me 1, so I'm left with 4x plus 2h minus 5. So that's the gradient of the chord PQ. Remember, when we're differentiating from first principles, we make h smaller and smaller. Okay, so Q gets closer and closer to P, and you can see then, as Q gets closer and closer to P, the chord then reduces in gradient in this diagram here, in this sense, and it actually, as Q gets ever so closer to P, it actually then homes in on that tangent at P. Okay, so what we say is, look, at P, okay, the gradient, okay, in other words, dy dx, so we need to write that down, will be the limit as we set h towards 0 of then the gradient of the chord PQ. So as h gets smaller and smaller, we then end up with our gradient dy dx, which is 4x then minus 5. Okay, because h goes to 0. And you could check, of course, with the original one, with the actual equation, of course, because you think about it here, when you differentiate normally, bring the powers down and so on, you'll get that. Yeah, that's exactly what we're looking for.